angles are 2 and 6. Okay, so is it possible to say that if alternate exterior angles are equal, then lines are parallel based on this relationship? Okay, in order to do this, I'm going to add one more angle in here really quickly. It's out of order, but we'll call that angle 7. And let's take a look at our proof. Again, we'll begin with our given information. Okay, so we know that angles 2 and 6 are equal to begin with. Okay, so if this is the case, what do we know about any other angle pairs in this? Again, we have SSI and AIA available. So if we can either show that a pair of angles, or the same side interior angles, are supplementary, then we have parallel lines. If we can show that alternate interior angles are equal, we have parallel lines. Yep, Sam. Okay, so if we say that the vertical angles, angles 6 and 4 are equal, and then angles 2 and 7 are equal by the fact that vertical angles, the first theorem that we proved. So we can make that statement. And then once we do this particular step, what we can state is, if we take this equation, what can we replace angle 2 with? Angle 2 is equivalent to angle 7. And what can we replace angle 6 with? Angle 6 can be replaced with angle 4. So again, what we did here was we simply substituted these values in. And then that allows us to now state, well, what do we know about angles 4 and 7? Those were alternate interior angles. And if alternate interior angles are equal, that's enough to show that lines are parallel by what we just saw in the last example, which was AIA. Okay, so in these 4 steps, we proved the following theorem. Here we had if alternate exterior angles are equal, then lines are parallel. And again, rather than writing that whole thing out every time, we can abbreviate it AEA.